So in this video, we're going to look at solving radical equations, and I'm going to try to make it as simple as possible because this can get complicated depending on the problem, but we'll try our best. So first of all, we all know what a radical is. It's like a square root or a cube root, something like that. Okay, now first of all, let's start here, because you've probably seen this before, you just don't realize that it was connected. So if I gave you x squared equals 4, a lot of you would know how to solve this because you would know the opposite of this exponent 2, or the inverse operation, would be a square root. Well, the relationship works the exact same way if we were to do it in the opposite order. So if I gave you the square root of x equals 4, the relationship still says, or the inverse operation still says, well, if the opposite of an exponent 2 is a square root, that means the opposite of a square root has to be the exponent 2. So if you want to solve a radical equation, you raise the square root, or whatever root you have, to the power of the index, which I know that's a little complicated to visualize, but I'll show you in a second. So essentially what happens here is the square root and the exponent 2, they cancel each other out, which means you're just left with x equals 4 squared, which would be 16. And that would be our answer. All right, so let me show you what I mean by the power of the index, because that can, like I said, that can be a little confusing. Like, let's switch this to a cube root, because it'll make it clear. Cube root of x equals, let's just say 2. Okay, now, if I want to know what the cube root of x is, in order to give me 2, I mean, I could go through a process to try to figure it out mentally, but eventually you can't do that. So now, what we're going to do is we're going to say, okay, I know that if this were a square root, if I said the square root of x equals 2, the relationship says, the inverse operations relationship says, well, I'm going to raise this to the power of 2 and this to the power of 2. Now, we actually got that 2 from the index, which the index of a square root is 2. All right, so now with that, you can probably tell me what I should raise each side to the power of, and it would be 3. So if you want to get rid of a cube root, you just raise each side to the power of 3. And that would solve this problem. We would say x, because the cube root and the exponent 3 are going to cancel each other out. So we would be left with x. We're going to say x is equal to 2 to the third, which would be 8. And we would be finished with this problem. So now, let's take that and let's make it more difficult. Okay? So the square root of x plus 5 equals 12. Now, the difference between the previous problems and this problem is now we don't have the square root isolated. So our job is to isolate this square root, or radical, which means get the radical by itself on one side. So you have to make sure you do that on every problem where you see a radical. Make sure you get the radical on one side by itself if you can. Okay? So here's what that would look like. Well, first of all, if we look, the left side of this equation, that's where the radical is. So the radical has plus 5 on the same side as the square root of x. So if you remember, what's the operation, or how do we get rid of plus 5? Well, that would be minus 5. And then what we do to one side, we do to the other. So now our square root is isolated. The square root of x is by itself equal to 7. So now, how do we get rid of a square root? Well, just like, once again, the opposite of exponent 2 is a square root, and the relationship works the opposite direction. So the opposite of a square root is the exponent of 2. Or you can just memorize or remember, set each side to the power of the index. So if the index is 2, raise each side to the power of 2, and that will figure, or will cancel, your radical, your exponent, and then you'll just set x equal to, or your variable equal to, whatever 7 squared is, which is 49. So there we go. All right, so now let's make this a little bit more difficult. So let me see. Let's see if I gave you the square root of, let's say the square root of, actually 10 plus the square root of x plus 7 equals 11. Okay, now this may look a little weird, but let's just go through the process. So once again, our first step is to make sure we isolate this radical. I know that it looks a little odd because there's a plus 7 in the radical, but if it's in the radical, then the whole radical is untouchable for right now. So we need to get rid of this positive 10, and we're adding here, so we know we're going to have to either add or subtract, and we would subtract. Okay, so the square root of x plus 7 equals 1. So now once again, act like this plus 7's not here, because what you can't do is say minus 7. That's what a lot of people try to do, but this square root's basically blocking that from happening. So we need to deal with the square root first. So how would we deal with the square root and do the inverse operation? Well, we would raise it to the power of 2. So we would say x plus 7 to the second power, well, the square root of that to the second power is going to cancel these two. So x plus 7 equals 1 squared, which is 1. And now we just have a one-step equation, and we can solve it by subtracting 7 on both sides. So x equals negative 6. All right, now let's look at another problem just so you can see it. Let's say I gave you, let me see here. Let's say I want to find a cube root, possibly. Maybe there's not a good one. Actually, I can give you a good one. So, let's say we want 7p minus 1, and let's do it this way. We'll make it the cube root of 7p minus 1 plus 11 equals 7. All right, now I'd suggest you pause this, try it out, see if you can do it. All right, so now our cube root, our radical, needs to be isolated. So is there anything on the left side that we need to move? And the answer is yes. We need to move this 11 by subtracting 11. So cube root 7p minus 1 equals negative 4. Yep, that looks right. So now the question is, we have our cube root isolated. How do we get rid of it? How do we get rid of the cube root? Like, what's the inverse? Well, it is the exponent 3. We raise each side to the power of 3. The cube root and the power of 3 will cancel each other out. So we're left with 7p minus 1 equals, let's see, that would be negative 4 times negative 4 is positive 16. Positive 16 times negative 4 is negative 64. All right? So now we've cleared off or cleared out the radical. So now we're ready to just solve this two-step equation. 7p minus 1 equals negative 64. And if you're on this video, I would imagine you can probably do this in your sleep, but let's go through it anyway. So we would add 1 on both sides. 7p equals negative 63. And then we would divide this 7, which I'm running out of room a little bit, but we'll make it work. I can do this, actually. I can do this to make it work. So 7p equals negative 63. All right, so now we just need to get rid of 7 by dividing. So p is going to equal negative 9. All right, now here's another setup you may see, and let me just show it to you real quick in case you come across it, okay? If I were to give you the same exact problem, okay, I won't make you rework it, obviously, but let's say I gave you the same exact problem, except instead of making this a cube root, I said 7p minus 1 to the 1/3 plus 11 equals 7, okay? What if you had that? Well, a lot of times people get to this and they think, oh, there's a fraction, I'm stuck. But as I've mentioned in a previous video, or I guess it's the last video before this, we can actually rewrite fraction exponents as radicals. There's also another way you can do this, but let's just go over it that way first, because that's usually the easiest way for most people to understand it. So remember from the last video, if we have, let's say, x to the 1/3, we said we could write that as the cube root of x. Now, if you need to go check out that video, I would, but let's continue. So that means instead of x, we have 7p minus 1. We could write this the cube root, 7p minus 1, and then we could go about our problem. All right, now here's another method. If you want to, if I wanted to make this 1/3 become 1 and essentially go away, I could just go ahead and raise it to the power of 3, and I'll show you why. Let's say I had x to the 1/3. That way we can get rid of some of the extra writing. And I raised it to the 3rd power. Well, hopefully you remember, when I raise a power to a power, I multiply exponents. Well, if I have x to the 3/3, isn't 3 divided by itself just 1? Yeah, so it would be x, which would simply eliminate the radical or the exponent. All right, so there's two ways you could go about it. You pick which method you like best. Now let me show you one more and then we'll be done. So here is a problem that a lot of people get to, and I'll just say lose their minds. Okay, so square root u minus 8 equals, and actually let's not use u because my u's look like 4. So let's just say x minus 8 equals the square root of 43 minus 2x. All right, now in most of my classes, when people get to this, they think, well, that looks extremely difficult. We haven't seen an example with 2 radicals yet. Well, let's go through it because it's a lot simpler than you might think. So if we were to try to isolate this radical, it's not possible because you can't really combine these radicals, and if you tried to, it wouldn't work. Okay, so what we do is we just skip the isolation step, and we figure out, okay, how do I get rid of one of these radicals, or maybe both of these radicals? Let's look. So if I raise each side to the power of something, it's going to get rid of this radical. What would that something be? That would be 2. And what we do to one side, we do to both sides. Now, if you notice, both of these radicals will cancel. So what ends up happening is we just end up with x minus 8 equals 43 minus 2x. And it's that simple. It seems like it should be harder, but the good thing is it's not. So now we could solve this, which this is, I guess, a multi-step equation. We'd want to add 8 to both sides, and we'd want to add 2x to both sides, so we'd get 3x equals 51. So then x has to equal 17. I mean, I did that pretty quick, but I have 2-step or multi-step equation videos, so check those out if you want. Now, there's one more thing. Well, before we move on, hopefully you see how simple that can be. Try your best not to let the radical on both sides scare you. Okay, you're still going to go about this the same exact way that you did. Now, there's one thing that I've yet to mention to you, and I'll just show you it very quickly. Okay, there's something with radicals called extraneous solutions. Okay, and if you've seen some of my other videos, we've talked about extraneous solutions before. Okay, extraneous solutions are fake solutions. Okay, they're I always remember it's extra, so we don't really need it. Like it's leftover. It's not a real. It's not needed. It's the best way to describe it. So in extraneous solutions, actually in a solution that doesn't work. And with radicals, radical equations, sometimes you can see those. Okay. Now, I'm not saying you definitely will, definitely won't. It's just your job to. It's your job to check your answers to see if they happen. Like, I'll show you a quick example, and this will be the last one. And you can practice it if you want, or if you're just completely burnt out from this video, then just watch. All right. Let's say I had the square root of 6w minus 5 equals -7. Okay, so we're going to raise each side to the power of 2, and we'll get 6w minus 5 equals positive 49. Okay, nothing crazy there. We're going to add 5, 6w equals 54, so then w is going to equal 9. Now, if we didn't check our answer, we'd say, yep, that's the solution, we're good to go. But watch what happens if we check our answer. So, at the very beginning, and I'll even start over so it looks clear. At the very beginning, we had the square root of 6w minus 5 equals negative 7, right? Well, we just said w equals 9, so let's check it. Because technically, if this is actually a solution, we can plug it back in, and the left side should equal the right. That's just, I think by now you probably understand that. So, let's do this. So we would have, let's see, 6 times 9, that would give us 54. 54 minus 5 is going to equal the square root of 49. Now, is the square root of 49 7 or negative 7? It's 7. And 7 does not equal negative 7, which means we would say that this is actually not a solution. It's extraneous. I'll just say extra period. And we would say the answer has no solutions now. So, once again, I'm not saying this will happen a ton, but it will happen. It can happen. So, be aware of extraneous solutions. The best way to avoid missing an easy problem, just check your answers. All you have to do is plug it back in. I know that it's not fun, I get it, but it'll keep you from answering w equals 9 when the actual answer's no solution. So, that would be it for this video.